Welcome to a new Simplygon tutorial. Today we will show you how to use Simplygon's Bone LOD function to reduce the number of bones influencing a mesh. We're using Maya for this tutorial, but of course the Simplygon UI is pretty much universal across all the software that we support. This means you should be able to follow along with this tutorial with your chosen supported application. A Bone LOD is a reduction algorithm that reduces the number of joints that influence a mesh. For example, finger joints may be disabled at a high distance LOD setting as they won't be visible from far away. In general use, it won't remove bones, though this is also an available option. I'll start by selecting the whole mesh, choosing Add LOD Component, and then choosing an advanced reduction. Although we aren't going to be using polygon reduction in this instance, this is where we can find the Bone LOD settings. So let's keep the reduction target triangle ratio at 1, meaning we will keep all the polygons in the mesh. And now we can have a look at the bone settings. We select a Use Bone Reducer in order to activate the algorithm. Remove Unused Bones will completely remove bones that are unused after the algorithm has been run. This can be a dangerous choice, especially if you're doing something like connecting a weapon to a socket and this socket is subsequently removed. So we will leave this off for now. Limit bones per vertex puts an absolute cap on the number of bones influencing each vertex determined by the slider below. This makes calculation itself cheaper, but animations will be less precise, so we'll leave this off for now too. The first control we will use is Bone Reduction Target Ratio. This control sets a rough target for the amount of bones to remove. 0.5 will keep about 50% of the bones. 1 will keep all of the bones. Just below it, the Target Bone Count also allows you to set an exact number of bones as a target. The next two sliders are for more advanced use cases. For now, we won't use them. So let's process this skeletal mesh with a 50% target. Okay, so we've completed the process and now we can test the LOD. We can keep the original here for comparison. So if I move the shoulder, it moves on both models. And the same with the wrist. But when moving the pinky, only one model moves. This bone's influence on the mesh has been disabled in the new LOD. Like with all Simplygon algorithms, the idea here is that the parts with the least amount of influence on the overall look will be removed. Okay, let's try again, but this time we will tell Simplygon which bones we want to remove. We can do this by using selection sets. For example, if we wanted the elbows to be removed, we could select them and create a selection set. We will call the set Remove Bones. Now we turn the bone reduction target bone ratio up to 1. This will keep all of the bones except the ones we choose in the Remove Bone Selection Set name. Use the drop-down to select our Remove Bones group. Finally, I will reselect all the geometry and run the reduction. Now that we're done, we can test it like before. If we take the shoulder and rotate it, both meshes respond. But if we choose the elbow, only the original LOD responds. The elbow joint no longer affects the mesh in our newly created LOD. This also applies to subsequent bones in the hierarchy, for example the wrist and fingers. If we undo that, we can have a look at manual bone protection. In order to protect bones, we use a selection set once again. Instead of selecting it in the Remove Bone Selection Set Name dropdown, we will choose this set under the Lock Bone Selection Set Name dropdown. In order to really show the effect, I'll set the bone reduction target bone ratio down to 0.1, which will aim to keep only 10% of the bones. Now we can run the reduction. As before, we can move both LODs at once to check what's happened. Selecting and rotating the elbows shows that both sets are animated, as the elbows were protected from reduction in our new LOD. If we select the neck, however, it's not been protected, so its influence on the mesh has been removed in our new LOD. One small piece of advice for Bone LOD in general: if you're going to remove a lot of bones, it's a good idea to have a bind pose that is similar to the standard pose in-game. If, for example, we use this T-pose as a bind pose but remove shoulder influence in one of our LODs, the arms would fly straight out like in this LOD. So do keep this in mind. Okay, now we are ready to take this into the engine and make sure everything is working well over there too. Okay, let's import these meshes into Unreal. As you can see here in my exports folder, I've got my 3 versions. I've got a 50% bones version, a version with protected elbows with a hard culling on the rest, and then the one where we kept all the bones apart from the elbows. Just for example purposes, I'm going to be importing these directly into the LOD chain of our robot Polly, just to show you how you can incorporate the Bone LOD reduction into your standard character reduction chain. I've labelled each of these as which LOD I'd be importing them into. Also, in the level I've got 4 instances of the mesh. The meshes are all the same at the moment, but I've got each one set to force a different LOD level using the force LOD model setting on each mesh. So let's go ahead and import. Okay, so let's open up Poly. And as you can see, Poly only has one LOD level at the moment. LOD 0. Okay, let's go down to LOD settings, then LOD import. I want to import the 50% bone reduction here. Okay, that's done. I'm quickly going to save that. Now let's quickly check if it's working. I'm just going to grab a pinky and contort it a little bit. Okay, that looks uncomfortable, but it works for our demonstration. If I switch this to an LOD 1, you can see that the fingers aren't being affected by the skeleton anymore, which is correct and what we saw on Maya, so everything is looking correct here. Okay, I'm just going to import my LOD 2 and 3 using the same import method. Okay, that's all imported now. I'm just going to save the asset and have a look at our level. It's like a big dance party over here. Everything is looking correct to me. The robot with hard culling but elbows protected is looking very strange indeed, but it is exactly correct and shows you how you can protect certain bones from the reduction. And then our version with removed elbows is looking correct as well. Fantastic. So there we go. We hope you've enjoyed this Bone LOD tutorial. For more information about our suite of tools and documentation, head to simplygon.com. Remember to hit the subscribe button and follow our social media channels to stay up to date with the latest news and tutorials from Simplygon.